Hello friends, I welcome you in lecture number 3 on curve fitting. In this lecture also we will discuss one more problem on fitting of second degree polynomial by the method of least squares, and this question was asked in GTU Winter 2019 exam. As we have discussed in earlier two lectures, suppose we want to fit a parabola or second degree polynomial, then we can start by assuming this form of the parabola y equal to a plus bx plus cx square, and then we solve the corresponding normal equations to decide these coefficients a, b and c. Now in this lecture we are not going to use this form of the second degree parabola. Instead of this we will change our variable, independent variable, from x to new independent variable, say u, by the change of origin. We can consider u equal to x minus some arbitrary number, say capital A. So what is the purpose of doing this type of change of independent variable? So sometimes if we consider this type of change of origin or this type of transformation, then our calculations will be minimized. So instead of using x as independent variable, we will consider u as independent variable, and we will start by assuming this form of the parabola. Instead of x, we will use u, a plus bu plus cu square, and we will solve the corresponding normal equations for these variables u and y, and after finding a, b and c, we will again put value of u in terms of x minus a, so that we get the original form of parabola in terms of x and y. So this is another approach to find out the parabola of best fit, or to fit the appropriate parabola to the given data. So this is called change of origin. Instead of using x as independent variable, we are using u as independent variable. By this type of substitution, u equal to x minus a. This capital A is our choice. Either we can use capital A from the given data, or we can select any choice for capital A. So I have done this problem using this change of origin type transformation. First I read this question. The following are the data on the drying time of a certain varnish and the amount of an additive that is intended to reduce the drying time. So here we are given x as the amount of additive in grams, and y denotes the drying time in hours. Values of x are 0, 1, 2, 3 up to 8, and these are the values of variable. Now I am not going to use x as independent variable, so what I can do, I can consider u equal to x minus some arbitrary choice for capital A. So here these are the values of independent variable x, and I will select capital A as the middle value. So here I will use this substitution for change of independent variable u equal to x minus 4, and I will start with the parabola of this form, y equal to a plus bu plus cu square, and we will write down the normal equations corresponding to this form of the parabola, and solving normal equations we will be able to decide these constants a, b and c. And here it is asked that fit a second degree polynomial by the method of least squares, and using result of first part we are asked to predict the drying time of the varnish when 6.5 grams of the additive is being used. Drying time is denoted by y, and amount of additive in grams is denoted by x. So we have to find out drying time y when amount of additive is x equal to 6.5 grams. So after finding appropriate parabola in first part, we have to find out the amount of drying time. We have to predict the drying time when the amount of additive is 6.5 grams. In short, we have to find out value of y corresponding to x equal to 6.5 grams. So I have written here x is independent and y is dependent variable in the given data. We change the independent variable x to the new independent variable u by the transformation u equal to x minus 4, and we assume this form of second degree polynomial y equal to a plus bu plus cu square, and the corresponding normal equations are: first we apply sigma on both sides of this equation, that is sigma y equal to n into a plus b sigma u plus c sigma u square. After that we multiply this by u and then we apply sigma on both sides. If I multiply this by u, I have a into u plus b into u square plus c into u cube, and then I take sigma on both sides of this equation and I obtain second normal equation, sigma uy equal to a sigma u, b sigma u square, c sigma u cube. And for third normal equation, I multiply each of these quantities by u and I write down third normal equation, sigma u square y equal to a times sigma u square, b times sigma u cube, and c times sigma u raised to 4. So to find out these normal equations, I have to first find out all these quantities, sigma u square, sigma u raised to 3, sigma u raised to 4, sigma u times y, and sigma u square times y. So this will suggest me to prepare the table, and from these quantities we have the idea that how many columns are required. First I have to write down x and y, then I have to find out value of u, which is x minus 4, then I will require u square, u raised to 3, u raised to 4, u into y, and u square into y. From these normal equations we will decide how many columns are required in the table. So I have prepared the table according to this. In the first two columns I have written values of x and y. Then I first find out these values of new independent variable u by this substitution x minus 4. So I start from this. 4 minus 4 is 0, 3 minus 4 minus 1, 2 minus 4 minus 2, 1 minus 4 minus 3, 0 minus 4, that is minus 4. Similarly 5 minus 4 1, 6 minus 4 2, 7 minus 4 is 3, 8 minus 4 is 4. Then u square, that is square of all these u values, square of minus 4 16, square of minus 3 9, minus 2 square 4, minus 1 square 1, and similarly I have taken square of each of these quantities. Third column is u raised to 3, so I can directly take cube of all of these quantities, or I can multiply these two quantities u and u square to obtain u raised to 3. So minus 4 into 16 minus 64, minus 3 times 9 minus 27, minus 2 into 4 minus 8, and similarly I have written all other values. Next column is u raised to 4, that we can find by taking square of u square. 16 square 256, 9 square 81, and similarly other values of u square are squared and written here. Then u times y, so I have to multiply these two columns. 12 into minus 4 minus 48, 10.5 into minus 3 minus 31.5, and similarly I have taken product of all these values, and here I have written all of those products. After that u square times y, so we can multiply this u square and y. 12 into 16 192, 9 into 10.5, 94.5, and similarly I have written other values. After that I have to take total for each of these columns which is required. So this is the total for y values, sigma y. If we take total of u values, it is 0. Then sigma u square becomes 60, sigma u raised to 3 becomes 0, sigma u raised to 4 is 708, and this is sigma u times y, this is sigma u square times y. So once we obtain all of these values, we can write in this way. From the table we find out this all sigma which is required for normal equations, and then we put these values in these normal equations. And here we require value of n. N means number of data points. So here it is starting from 0 and ends up to 8. That means value of n is 9. So we substitute all those values, and we can see for first equation we have n into a, that is 9 into a, sigma u into b, but sigma u is 0, and sigma u square into c, sigma u square is 60. So first equation is 9 into a plus 6 into c equal to sigma y. Sigma y is 80.5. So this is my first normal equation. In second normal equation we have sigma u and sigma u raised to 3 which are both 0. We can see sigma u raised to 3 is 0, sigma u is 0, and sigma u square is 60. So second normal equation will give me 60 times b equal to sigma u into y, which is minus 23. So you can see we can directly find out value of b by solving this second equation. Third normal equation is sigma u square into a. Sigma u square is 60, so I have 60 into a. Sigma u raised to 3 into b. Sigma u raised to 3 is 0. Sigma u raised to 4 is 708. So here I have 708 times c. Sigma u square into y is 593. So after putting all these values, we obtain these three normal equations which I just explained. So you can compare this problem with the problem which we have solved in lecture number 2. Here we are able to solve these equations easily. We can directly find out constant b from third equation, and we can easily solve equation number 2 and 4 either by Cramer's rule or by trial and error. So this is the benefit of changing the independent variable. Here I change the independent variable from x to u, and you can see I obtain these two summations as 0. Sigma u becomes 0, sigma u raised to 3 becomes 0, and our calculations are also minimized. So you can see if I am taking x, and then I will require x square, x raised to 3, x raised to 4. So the values corresponding to 5 will be 25, then 125, then 5 raised to 4. So you can compare these values here. The values for x equal to 5 and for u equal to 1. If I take u equal to 1, I have 1, 1, 1 for each of these values. But if I take x equal to 5, I will have 5 square, that is 25, 5 raised to 3 and 5 raised to 4. So our calculations are minimized. So that is the benefit of change of origin or changing the independent variable. Now first we solve equation number 3. So we can see b equal to minus 23 divided by 60, that is minus 0.3833, and we can solve equation number 2 and 4 using Cramer's rule. So for Cramer's rule, what we require? First we require the determinant of coefficients. first we have to decide the determinant D of coefficients of A and C. First column is for coefficients of A, that is 9 and 60. Second column for coefficients of C, that is 60 and 708. Then we require the determinant corresponding to variable A. So how to write down that determinant? So that determinant can be written by replacing column corresponding to A by the column of constants on the right hand side. So instead of 960, I will write down 80.5 and 593, and I will keep second column for B as it is, not for B, for C. Similarly, to write down the determinant corresponding to C, I will replace this column corresponding to C by the column of constants. That is, I will write 80.5 and 593, or I will replace this column which corresponds to constant or variable C by the column of constants on the right hand side, and I keep this column as it is. And then value of constant or variable A will be division of this D suffix A and D, and value of C will be value of determinant corresponding to C divided by D. This is the idea of Cramer's rule, and we can apply Cramer's rule only if this determinant is non-zero. So I have done all these things. We solve equation number 2 and 4 by Cramer's rule. First we write down this determinant of coefficients corresponding to variables A and C. So D turns out to be 2772. Then D suffix A, so that I have written by replacing column corresponding to A by the column of constants on the right hand side, and this turns out to be 21414. Similarly, D suffix C, so for that I have replaced this column by the constants and I keep this column as it is. D suffix C turns out to be 507, and by Cramer's rule A equal to D suffix A divided by D, and by substituting values we obtain A equal to 7.7251. C turns out to be D suffix C divided by D, 507 divided by value of D 2772, that turns out to be 0.1829. So now we have values of all the constants A, B and C. B is minus 0.3833 and A and C are is by Cramer's rule. So now we substitute these values in our assumed form, y equal to A plus B u plus C u square. So putting these values of A, B and C in equation number 1 which we have given for this equation, we obtain this form of parabola in terms of variables u and y. So this is not our answer. Our original variable is u, and we have obtained second degree polynomial in terms of independent variable u. So in the next step I have to replace u by x minus 4. So now I put u equal to x minus 4 here and here. In the next step I multiply this constant with x and 4, and I expand this x square minus 2 into 4 into x, that is minus 8x plus 16. I further simplify. For that I add these two and I multiply 0.1829 by each of these three terms, and I obtain all these terms here. And then collecting coefficients of constant term x and x square, I obtain this second degree polynomial for the given data, y equal to 12.1847 minus 1.8465x plus 0.1829 x square. I have done all these calculations by fixing my calculator up to 4 decimal places, and this is the required second degree polynomial. So this finishes part 1 of our question. In part 2, we are given value of x and we have to find out corresponding value of y for that given value of x. So we are asked to find out value of y when x is 6.5 grams. So we put x equal to 6.5 grams in equation number 5, and we find that corresponding value of drying time, that is y, is 7.6901 hours. So in this way we can solve this type of real life problems by considering this curve fitting concept. Here we are asked to find out the drying time in hours for x equal to 6.5 grams. If the additive which is used is 6.5 grams, then what will be the corresponding drying time? So we can predict the drying time of the varnish whenever we are given some amount of additive that is used for this varnish. So we can solve this type of problems using this concept of fitting of curves. So I hope you like this lecture. I have tried my best to explain this fitting of second degree polynomial by the change of variables. What is new thing in this lecture is we have employed the change of variable from x to new independent variable, and we find that our calculations are minimized if we use this change of origin. Instead of using original values of given independent variable, we are transforming given independent variable to new independent variable, and we find that our calculations are minimized up to certain extent and we are able to solve the normal equations easily. We are not applying any Gauss elimination here. Okay, fine. So I stop here. We will be continuing in this series in upcoming lectures. Thanks for watching.